Welcome back to the channel where a math student doesn't have any content. Anyways, today we'll be learning about reflections. As you can see here, this is a wait, x, y. This point is 1, 3. This point is 1, 5, 4, 5, 4, 3. So, you would want to dial. So, we're going to rotate it 90 degrees counterclockwise. So, so, as you can see here, we're going to change this 3, 1 into a, if we were to change it, this would mean that this would be over here, 90 degrees clockwise, would mean that it will change, it will become 90 degrees clockwise to negative 3 and 1. Now, what? Have you seen any difference? 3, 1, and then I turn to negative 3, 1. Now I'll give you some time to think about this. Okay, time's up. So now, if you were to turn 90 degrees if you were to turn 90 degrees clockwise or 270 degrees clockwise, the x value would change. Now, what if you went 90 degrees clockwise? Now, we'll be seeing this. It will change to this. So now it became a 31 to a 3 negative 1. Now, do you see? Now, if we were to turn it 180 degrees clockwise, it would become this point over here. 3, 1, 2, negative 3, negative 1. Okay, so, as you can see here, there's a pattern. Okay, we're gonna call this the first quartile. I think that was the second quartile, third quartile, and fourth quartile for now, because I don't remember my quartiles. Okay, so first quartile, if it's in the first quartile, its x would be negative. Or if the x was, the first quartile, the x is always negative. The second quartile, everything's positive. The third quartile is over here. So the third quartile, I think this one was third. Okay, so the third quartile would make the y value negative. The fourth quartile would make both values negative. So, so as you can see here, there is a very simple thing. And now, it's time to make our square. So we move this 3 to the left in order to make the next point. Now, 3 down, not 3 to the left. So now, we move this 2 up. This one 2 up. Oops. So now, you move this down, these down, but like this. You're done. It might not look pretty on mine. So now you do the same thing, but this time you do it like this. Next, next, this one. So the next one is this one. You move this this, and this. You create the rectangle. You got yourselves a reflection. Oh wait. No wait, this is the rotations. Ah, nut. Anyways, we'll just change this. Rotation. So we're gonna change. So this is rotations. If it was to go 45 degrees clockwise, it would change anything actually. Actually, yeah, it would change something, but for now, this is 7th grade math. We're just gonna learn the basics. 90 degrees clockwise, 270 degrees clockwise, 180 degrees clockwise, negative 270, negative 90, negative 180s, and 360s. So as you can see here, we start at this. 270 counterclockwise would mean over here. 180 degrees clockwise or counterclockwise would still put in the same position. 360 degrees clockwise or 360 degrees counterclockwise will keep you over here. So, as I babble on, now let's try doing a rotate. Now let's do reflections. Just wait, erase. Incomplete. So for today, we're going to learn about reflections and rotation. The first one is about rotations. Oh wait. Also, the center rotation. Wait, we're still learning about rotations. So as you can see here, this is going to be my center rotation. Rotate it to 70 degrees, you will get it over here. But if the center rotation is over here, and it's over here, 270 would mean over here. Oh, no, that's... Wait. Yeah, it would be over here. So, the center rotation is what you need to know before you start. Because if you did like... So, if the center rotation was up here, and you drew it down here thinking it was 90 degrees clockwise and you thought the center rotation was over here, it'd be incorrect. The answer would be over here. So now I have taught you about the rotations. Now it's time for reflections. Guys, I forgot to tell you about center rotation. This is how you spell it. Center of rotations. Center rotation, not rotations. This is how you spell center rotation. And center rotation. So now, this is gonna be our model. 2, 2, 2. Okay, so this is gonna be our point. Shapes are different because you have to get every point at the exact same one. So we're gonna do shapes actually. Point 2, point 3. So this is a triangle. Now it says that you have to reflect the triangle across the x-axis. Which one will you do? A over here, or B over here. Now, you figure it out. 10 seconds. Time's up. So now, I say across the x-axis. This is our x-axis. So that means we're going to go over here. This one is across the y-axis, which is not what we want. So we have to cross that one out. So this is how you do it. So now, you might have something like this. Oops. So I'm going to take it over here. 2, 1, 2, 1, 2, 1, 2. So now, this is going to be our triangle now. It says that we have to reflect it across the x-axis, then the y-axis. So, is the answer this? Where we reflect it across the x-axis like it said, and then reflect it across the y-axis. Or do we reflect it across the y-axis and then reflect it across the x-axis? Now, what do we do? A or B? 5 seconds this time. Time's up. The answer is either, actually, because they're both the same answer. They give out the same answer. As you could see here, this one, if reflected across the x-axis, will still get you this. Even though this will get a different root. Both of them did different roots, but still, both give you the same answer. Now, you might be thinking, is there a pattern? Well, there is actually. It's the same thing as the rotations. This one has a negative y, negative y. Both. Plus for both. Minus for both. And the minus for x. First quartile is this. They're all the same. This rule. The rotations rule about the quartiles are the same thing as this one, because the quartiles are still the same. Now, instead of going 90 degrees, you are faced with the across the x-axis or across the y-axis. And maybe that's it. Did I forget anything? Let's just check for a bit. Maybe I have nothing else to say. Yeah, this is actually it. So, this is reflection. This, you might be faced with a heavier problem, but this is easier than rotations, because rotations require more thinking. This one, not much. It's really not that much. So anyways, if you like the video, please subscribe and like this video. And this is my only video that I'm going to say that, because I really don't care anymore. So, goodbye.